Okay, so here we have the equation x equals t plus sine t, and the equation y equals t minus cosine t. And then you're going to find the, essentially the slope dy over dx plus the second derivative of y over the second derivative of x. Or the equation for that. So here's what we're going to do. So you got dy, or dx over dt equals 1 plus cosine t, which is pretty straightforward, and then straightforward as well as dy over dt, which is 1 plus sine t. And you take those two, and I'm going to solve for the first one, dy over dx, just because it's all right here. And you get that it's 1 plus sine t over 1 plus cosine t. And then from here on, you're going to want to take these first two derivatives that you found, and then find their second derivatives, which would be d2x over dt to the second is negative sine t, and d2y over dt squared is cosine t. And then you're going to want to take this and plug this into the equation. Now the equation is, I didn't write it down, but it essentially is dx over dt times d2y over dt squared minus dy over dt times the d2x over dt squared all over dx dt cubed. So that ends up being 1 plus cosine t minus 1 plus sine t negative sine t over 1 plus cosine t cubed. And then you start to distribute and discover that you're going to see some recognizable identities here, such as that you're going to see that cosine squared t and sine squared t pop up, which that, as we all know, that equals 1. So then you end up with 1 plus cosine t plus sine t over 1 plus cosine t cubed. So that's the final answer.